device classification. So first, I'd like to thank the guys at Varnish for inviting me here. Thank you very much, and Vimeo for hosting us. I don't know who here works for Vimeo, but thank you. So I'm not sure why I changed my bullet points to whatever symbol that is, but I'll just have to roll with that. So a quick agenda. What is dClass? A brief history of device detection. I know that's kind of a hot topic for some people. Device classification in Varnish using dClass. Device classification developers, what this means for developers. Apache Device Map, I'll talk about that a little bit. And finally, the future of dClass. Because, the technology does it's used in many different ways outside of this kind of domain. So, what is dClass? So, it's a classification engine. It's actually a pattern index. So, these patterns kind of tell you things. So, in dClass, you index these patterns in. And then you kind of pass your data into dClass, and it matches up these patterns to your data. And basically, that's classification. It's a way of doing classification. So, as similar as this looks to search, it's actually very different than search. So, let me give you an example. So, basically search is discovery, dClass is classification. So, as an example, let's say you're looking for your keys. That's search. Classification will tell you that what you're holding in your hand is a pair of keys and what they're used for. So that's kind of where I'm going to. When you look at search and you look at dClass, they kind of look like they're, it's indexed. It's kind of indexed data, but they approach it at very different angles. So, for example, dClass actually indexes your searches. And these searches are just patterns. It's kind of like, these. I call them patterns because it's kind of like a sequence of data. They can have dependencies and other attributes. And you have lots and lots of different patterns. And these aren't just any old patterns, because if we want to go ahead and index patterns, you can find patterns everywhere. These patterns are kind of based, what I say, these patterns represent knowledge. You have to be very, you just have to say, what, when you don't, you have to basically be very specific and say, this pattern means X, this pattern means Y. So in that sense, we can say that dClass indexes knowledge. Okay. So how does dClass work? So I'm not going to go into too many of the details here, but it's basically like a highly, highly tuned pattern index. One of the cool things it does is that every pattern has a very unique and has its own path in the data structure. So it's basically an algorithm, basically an algorithm. It's like an algorithm, algorithmic efficiency. Which allows it to scale, and there's also a lot of different memory techniques which reduce the memory footprint. So that's kind of why I say there, algorithms equals speed, memory efficiency equals speed. Now I should also put another bullet point on there, simplicity. Simplicity equals speed. dClass supports regular expressions, and just another point, when you load in what I call the DDR, basically all the device patterns, memory usage is probably right at 2 megs. And classification runtime is probably a handful of microseconds. So that just gives you the idea of the efficiency I'm talking about. It's very fast, very efficient, and highly, highly accurate. So it supports regular expressions. And this is an important point, is that all regular expressions are precompiled, meaning that in index time it goes ahead and compiles all those regular expressions down into the representative patterns in the index. And basically the point I want to say here is that anytime you can do any kind of pre-indexing or pre-compute work, you want to do it. What that buys you is it buys you, basically at classification time, it's a very simple algorithm. The less you're doing during classification, the simpler it is. it keeps your code simple. It also, gives you higher performance because you're not sitting there trying to do something. You're not being repetitive. You're doing the work up front, index it, done. Keep it simple. dClass also breaks out dead input by walking the input as it walks the pattern tree. So to give you an example of this, like let's say we're talking about the device detection domain, and we're looking at a user agent. It actually only looks at about a quarter of that user agent string. 75% of that string is ignored because it just knows that it knows a dead pattern when it sees one. Because it's walking these two structures in lockstep, it just knows that this is not a viable pattern. Move on, move on, move on. So, when we're talking about the device detection domain, it's very efficient. It's only looking at about a quarter of that string, and it's actually doing very few memory lookups too to go ahead and deduce what it's looking at. So that goes to my final point: concise patterns, high performance. You don't need to put a lot. You don't have to be very verbose. Some people go ahead and put entire gigantic strings to do their device detection, and that's unnecessary. When you're doing something like pattern classification, just get the minimum in there. If you see this little part, then you have a positive hit on something. And this in dClass, that manifests itself as just higher performance. So keep it concise, and I think that goes for a lot of things, not just classification. Last one got cut off. Okay, so brief history of device detection. So we're kind of switch gears here. So there's a field called the user agent header. Back in the early days of HTTP and the web, this was kind of designed with content negotiation in mind. But like all things in the web, things change. What really started happening? Well, first, everything was kind of evolving at a very steady, constant state. We had browsers and screen sizes, network speed, and CPU speeds were all just kind of, evolving, at a kind of lockstep. So, and we also had this thing where browsers didn't want to be left behind, so they started emulating each other in the user agent header, and that's why today we have what I call user agent boilerplate. We just have these stock strings in there, which were meant to kind of deceive web servers into thinking that they were something else. They just now became user agent boilerplate. It kind of made things hard for developers to try to use that in the future to kind of get something useful out of it. So basically, for a while, the user agent string just kind of turned into obscurity. It was still being used. Browsers still use it to kind of broadcast who they are, but it's just hard to use. So, then we get into the current time, and we have mobile devices and tablets, and that was kind of the game changer. I don't think mobile devices want to pretend that they're a desktop browser. So it was hard, but they still had to maintain those standards just in case there was some ancient web server that decided to serve them, not HTML, but that's a different topic altogether. So we have these new devices, and these new devices led to, basically it fragmented the space. And that kind of led to a little bit of developer and kind of approach fragmentation. The one thing that kind of kept everything together is WebKit. WebKit is the rendering engine in pretty much all cell phones, all tablets, and a lot of desktops. So, all Apple mobile phones had WebKit. All Android mobile phones had WebKit. Most latest BlackBerry mobile phones have WebKit. Obviously, most tablets, because they're Apple or Android, and then Safari and Chrome all use WebKit. So, the developers at WebKit went ahead and kind of put forth their approach to how do we go ahead and allow developers to kind of target these different devices, because it was a problem, because you didn't have the same, you had very different requirements on these devices, which I'll get to on this next slide. So server-side device detection. There we go. Okay, so first of all, it's not detection, it's classification. There's a few reasons I call it classification, because that's what it is, and kind of moves us away from, saying, oh, well, this is this device, let's be very specific. Classification is more of a general, this is what we're dealing, this is the breed or the species or whatever. So the device classes we care most about, in my opinion, smartphones, tablets, desktop browsers, crawlers, and I have feature phones on there too. So let's think about some of the requirements of these different devices. So smartphones, generally, low bandwidth, low power, low CPU, generally a younger user, and it's growing. Believe it or not, if you're making a website today, like that should probably be the first site you want to make, depending on who your audience is. There's a lot more details that can go into that choice, but smartphones are big. You should always be thinking and building towards that smartphone experience. Tablets, kind of the same, just a lot more real estate. And something else between smartphone and tablets, we have touch. We have a touch interface. When you think about browsers, we have a little bit more resources. We have more memory. We have more processing capabilities. Usually have faster bandwidth, and maybe even an older demographic. And we have a mouse. So, mouses are a lot more precise than, using your fingers. Web crawlers. Web crawlers are an interesting thing. They like data. So, just if you want to detect them and you want to feed them what they want, classify them. Give them data. You don't have to serve them a website or a web page. Finally, feature phones. I don't think a lot of people see them. I don't know if a lot of people will care about them. In some industries, you might see them. So it's available. And also, browser targeting is available. So we can take that desktop browser class, and we can even break it up against, we can even say, IE users, Chrome users, Firefox users. And there's a reason later on I'll explain, what this buys us, because this does buy us. By doing this classification, we do get a lot of benefits. All right, device detection challenges. If this was easy, I wouldn't be here giving you this presentation. So device detection used to be difficult. We had that problem with kind of emulation. We kind of had that thing where the user agent field was kind of meant to deceive. So you're going to see a lot of false positives in there. That kind of leads to messy logic. It was non-performant. And finally, we have devices being released all the time. So it's a messy, I wouldn't say it's a hard problem, but it's a messy problem. It's a problem with a lot of scope. So, it needs to be properly approached. So dClass and varnish is clean and performant. I say it's clean because a lot of that logic is it's baked into dClass and hidden from you. It's performant, it's fast. There's a lot of solutions out there which they're just not going to be as fast. They use a database, they use some sort of service. This is all just baked in. We also have projects like Device Map, formerly OpenDDR, and other commercial offerings that stay on top of releases. So you go back to those first 2 points, we kind of hit them both there. We have a good solution which kind of captures a lot of that messy logic, and then we have partners or services which then give us updated monthly DDRs, device detection repositories. So, the final thing people say is, well, we have to constantly be updating our DDR. Well, you don't constantly have to be doing it, but several times a year is probably good. And, my question is, how often do you update your website? If you update your website once every few years, you're probably not going to care a lot about staying up to date with the devices out there. If you're in, let's say, weekly, monthly, or quarterly schedule, it might be a good idea to just update your DDRs on that schedule. It's just as simple as downloading a file, and I'll explain it in a little little bit. It's a very simple process. Okay, so I kind of already said, the solution is completely contained within Varnish. It doesn't require a database, it doesn't require any services, it doesn't require anything. It just requires you to compile a module and use it. And this is something I really like about Varnish, is that it's expressive. I don't know how other people feel about it, but anytime I can go ahead and kind of write the logic that I want, in configuration, I think that's a great thing. So just to give you an example of how we can use device classification in our caching layer. First example is, okay, we have a request, we classify it, we just simply send that header back to the backend. Let the backend make a choice. Do we want to serve something custom? That's it. We can go ahead and make sure that that header is then used to vary, so we don't kind of overwrite our cache if we do serve something different. Another way we can do it is by kind of rewriting the request. We can either rewrite back to the client using a 301 or 302, or we can do a backend rewrite. And what that does is basically, when we rewrite requests, we get this thing called partitioning. And I think partitioning is a very important thing, not just in code, but just in general with your data. When you rewrite based on device classification, you're basically making a call to either a new domain or maybe a different file. So you're kind of partitioning any sort of device-specific logic and code. And we can even mix and match these things if you want. So you can go ahead and try a rewrite. If that rewrite fails, go ahead and just do the original request with the header. So this kind of gets tricky when we talk about CDNs. If you use Varnish, you may use a CDN. And the problem is that we are embedding kind of custom routing logic or custom rendering logic at origin, but the CDN, it's going to be tricky for them to kind of understand this. So there's a few ways to kind of handle this. One way is use cookies. Request comes in, it's unclassified, or a user comes in, they're unclassified. Go ahead and put their classification into a cookie, and then we can go ahead and hopefully the CDN support system instruct the CDN, hey, if they have this cookie, they don't have to come all the way back to origin. Go ahead and serve them something that matches their request and whatever values in the cookie. Something else I say here is maybe just find a smarter CDN which could maybe handle this, and hopefully in the future this will happen. Finally, Varnish can even serve device classification JSON for client-side use. Just an example of how I've used that is on a website. We had some embedded videos, and we wanted that video to autoplay for desktop users, but we didn't want that video to autoplay for mobile phones or for tablets. So what we did was we made a simple call to our device classification service. If they told us that this was a desktop device, we started the video on page load.
There's a trick there to avoid the expectation call.
Wait, say it again?
There's a trick with regards to instead of doing the expectation call, this works great for GIP2. Smash in a cookie. And just read the other cookie.
Say it again? Explain that?
On the page, instead of doing a separate JSON request, set a cookie.
Oh, you're right. You put the device classification in a cookie?
Yeah.
Yeah, right. That would be, yeah. That's a good point.
GIP data.
Yeah. Okay. Sorry. Okay, there should be links on there. So I'll go ahead and so I was going to go ahead and show you how to compile dClass, but the link's not up there, so I'll just explain. So dClass is on GitHub. If you go to Google, just go ahead and search dClass. It's actually listed on the Weather Channel because I developed it when I was at Weather Channel. Go to GitHub. You can either clone the project or you can just download the zip. And then within there, you'll see a directory called servers, and within there, you'll see a directory for Varnish. Go ahead into.
Go on.
That's fine. I can just explain. Okay, that's not a big deal. It's probably better I explain it. you don't want to see code. So then you'll see a directory. There's very clear instructions. Go ahead and build a module. You can get a shared object. That's the standard vmod. Go ahead and put it into the Varnish vmod directory, and that's it. You're up and running. Actually, I did want to show you DCL, so I will have to somehow break out of this. Can you help? So open up a web browser. Chrome? Yeah, and then okay. So hopefully it shows up there. Yeah, there it is. Yeah. Great. So here's what I was talking about in the servers directory, source. Just go ahead and run make in here. It builds the module. You're gonna get a dClass vmod. Put that into Varnish. You're all set. So now let's go over the configuration. Okay, so you can see right here, import the module. So right here, we go ahead and we initialize the module. And this is what I was saying, all it requires is just, so that dtree file is kind of the dClass pattern index, precompiled, precompiled. So go ahead and load it. And then also here, we're actually loading a browser dtree file as well that does browser detection. So right here, you can see I actually go ahead and we classify. So we go ahead and we classify the request, and we see we classify in the user agent, and we put the output of this, which is just a string, into this header field called dClass OpenDDR. This is just another way to do it, since I was just showing that we have two indexes, so we can either drop that index position or put it there. And we go ahead and do the same thing. We pass the user agent back into classify. This time we're classifying against the first or second index. It's zero notation. And that index is the browser index. And we go ahead and we put that output to dClass browser. Now that we've classified, we actually have access to all the different device attributes. So here, I'm going ahead and I'm actually going to go ahead and use those device classes I said before. So the first thing I do is I label the device as an unknown device. And it's important that you kind of take care of devices you can't classify. And in most of the cases, if you don't know what it is, just serve it the default view. So if it's a tablet, I say it's a tablet. If it's a wireless device, which is a cell phone, and the input is touch, it's a smartphone. If it's a wireless device, and this is like else if, so the logic falls out of that. So if it's just a wireless device, it's a phone. If it's a crawler, it's a crawler. And then finally desktop, that's the desktop device. So now we actually have our 5 device classes here. And then you can go ahead and we can simply, so right now it's already in the header called dClass type. If we want to go ahead and rewrite the URL, you can rewrite the URL based on what the type is. Right here, if we are going to go ahead and serve multiple views on the same URL, it's important to go ahead and put that type into the hash data. Otherwise, you're going to get cache overwrites. And finally, I went ahead and just showed, here's a service. So what someone back there recommended was putting this actual value into a cookie. It's a very acceptable solution. Or we actually have a service right here, which can be called and actually returns all that classification data, either in plain text or JSON form. And we can see here that we're returning a lot of different attributes about the device. Vendor, display, size, input devices. Some of these are important. Honestly, I only think the only things that are important are just that device classification. What is the type? Is it a desktop? Is it a phone? Is it a tablet? Okay, so this. bear with me. Okay. So updating your DDR, and this is another feature I really like about Varnish. I'm not sure if you guys, it was actually hard for me to find documentation on this, but you can actually just use a VCL load and a VCL use. And on VCL load, it actually hits that init section. It actually goes ahead and loads, reloads the index, and then when you use VCL use, it'll actually activate that VCL. And basically, what you've done is you've just done a no downtime update of your DDR. Apache Device Map has monthly DDR updates. So all you really need to do is just once a month, maybe set aside 5-10 minutes, or maybe once every few months, download the latest DDR, go ahead and just do VCL load, VCL use, and you're up to date. That's actually very simple. That's simple. I don't know why. Very straightforward. So vendors, admins, and sysops, offer this as a service. It's free. dClass is free. Apache Device Map offers their services for free. This is part of Apache. Has value. Anytime you can offer a service that's free and has value, you should do it. It's a good thing. Okay, device classification developers. Device classification will simplify your code. So that kind of goes back to the whole idea of partitioning. Anytime we can partition our logic or partition our presentation into their own either file or their own module, you actually do get some simplification. One of the complaints people have about the current front-end approach to kind of different device layouts is just the complexity. Sure, you can go ahead and have little parts of your UI render on different screen widths, but what happens when you want to actually interact with that part of that UI? You need to embed that logic into other parts, and you're now talking about things that are outside of presentation, and it starts getting complex. Whereas if we have a way that we can just kind of partition all this logic into its own kind of, literally into its own file, we lose all that kind of complexity, and it just becomes, very straightforward. We don't have to worry about code existing or not existing. If it's in the file, if that presentation is in there, you're going to use it. Device classification is just another backend parameter, just like on the front end. It could be a front end parameter as well. It's completely transparent to the web stack. Meaning it works with Java, works with Ruby, works with Python, PHP. And it's transparent, kind of like load balancing and caching. The developer doesn't have to worry about who's doing this or how do I get it. It's just provided. And projects like dClass and Device Map have made device classification more accessible than ever. So before, it was hard to kind of do this. Now it's easy. Okay, Apache Device Map. So Apache Device Map basically was born out of OpenDDR. So OpenDDR, this is about 2-3 years ago, is basically a collection of what I say like-minded people who wanted to get together and open source all things device detection. So we made OpenDDR, and we were, I think, successful. Apache noticed and they adopted the project. So now it is an incubator. It's a Apache incubator project. And we are moving it forward in full force. So we just started getting our legs, in the last few months. And so look for, if you go to the website, it might look a little bit bare, but the data's there, the DDR is there, the code is there. Meaning, the code is there in the project. So those big changes are just going to be, just kind of solidifying, what the goals of the project are, look and feel, website, stuff like that. It is an Apache project, so it is open source. So contribution is very helpful. So if you have an issue or anything, tell us and contribute. That's always a good thing. So finally, dClass in the future. So kind of what I was saying before is that dClass is a powerful classification engine. I personally am using it in some of my other projects to do some things outside of the realm of device detection. So better classification leads to things like higher order reasoning and richer interactions. And we can see that in the whole device classification domain as well. Classifying a device allows Varnish to better reason with that request. And it gives a richer interaction because we can go ahead and return a more customized response that kind of fits the device better. That also applies to some of the other domains that dClass is being used in. Personally, I'm using it for kind of like natural language, text, and audio processing because it is just a pattern index. So in this example of that, I have a project called WebClass, which kind of has, it's kind of going to be like an open source collection of pattern indexes. And you can check it out if this sort of stuff interests you. And you can see that device detection is just one small aspect of kind of a bigger environment or bigger ecosystem of pattern classifiers. So if that stuff interests you, check it out. Let me know. And I'm open to contributions. So. Okay, that's it. I'm always available. I'm always very helpful. So shoot me an email. Find me on LinkedIn. Let me know if you have any questions. Or do anyone here have questions now? Yes.
So what's the coverage compared to like Device Atlas or Sancho workflow?
Yeah, so I haven't actually looked at, I haven't actually personally done any sort of side-by-side comparisons. What I do know is that when we first started OpenDDR, which was about 3 years ago, the coverage in Wurfel was, I'm not one to, talk down about like any product, but it was poor. It was very poor. And that's why that's why when I took this kind of classification approach, I was very pleased with the results. I mean, we were getting extremely high levels of accuracy, and the things that we were missing were just kind of like garbage, and just the whole approach of just kind of classifying, and the stuff we were missing, weren't bad things. We just send them to, the standard resources. So when I go ahead and say, accuracy is in the high 90%, that's true. I can't say today what those other projects offer in terms of accuracy, but it's, the leveling field has leveled, it's kind of leveled out because, this is an open source project, so they are learning stuff from what we did, and we learned stuff from what they did. So it's probably pretty close. But in terms of performance and speed, dClass and Device Map, by far the fastest. I'm not sure. I actually haven't even looked at their implementation. But, this is all open source, so if someone wants to go ahead and do that sort of performance benchmark, let me know. I'd love to hear. Any other questions? Yes?
Can I identify now specific hardware manufacturer and a specific model?
Yes. So how that works is that, you need, that information needs to be known, ahead of time. So when we see, a Samsung like SGH442, we go ahead and we say, yeah, this is a Samsung, here's the model, here's everything else. So depending on, you'd have to go ahead and, so, you can either put that information into the DDR yourself, but it does come, I think, preloaded in there. We do put the vendor, we put the manufacturer, and the model number. But, like I said, it's a very extendable, the DDR is very extendable. So if you want to go ahead and add in, the weight of the object or the weight of the phone, you can go ahead and put that in there. You just need to find all that data. So yeah, so what I'm saying is dClass can know the weight of your of the request, or the device making the request if you wanted it to. Any other questions? All right, thank you guys.